Okay. Hi. So we're done with lists for now, and today we get to start a totally new topic that I find very cool. It's called inheritance. Shall we talk about inheritance? It's kind of quiet. I guess the mic is maybe like on its last legs. Okay. So, what's inheritance? Why do we need it? Why are we spending 4 lectures on this thing? So, in the last 4 lectures, we built the beautiful A list, which had these methods. You could add to it, you could get items, you could remove items. And we also built the beautiful S list, which had these methods. You could add items, you could insert items, you could remove items. I'll get to that. So, A list, it's beautiful. It has these methods. S list is beautiful. It has basically the same methods. So let's see how someone in the real world might use these classes that we built. So suppose maybe I want to write some code that finds the longest word in a list of words. You do not have to read this code and understand what it does, but somehow it takes in a list, an S list of words. It goes through them and tries to find the longest word in the list. So for example, if I passed in, here's a copy of the code. If I passed in, like elk are watching, and then I printed out what the longest word in that string is, then I should get watching, because that's the longest word in that list of words. I guess it'll eventually build, and I get watching, because watching is the longest word. OK, great. But there's a minor problem, which is this is all good if the user chose to use an S list and then called my word utils longest method. But what if the user actually said, you know what, I'm going to put the words in my list, not in an S list, but I'm going to put my words in an A list instead? Well, now we have a problem, because if I read my words into an A list, this longest method, Java starts complaining, and it says, I thought you were going to give me an S list, but you gave me an A list instead. They don't match, and the types don't match, so I'm not going to compile this program. So we have a problem. If I would like this method to take in an A list, it no longer works. So how do we fix this? I guess I spoiled it because I accidentally hit the next slide. But one possible idea is, well, maybe I will make a copy of the longest method. And instead of taking in an S list, it'll be the exact same method, but I'll make it take in an A list. So I could do that. So it would look like this. I'd have 2 longest methods. One of them takes in an S list. One of them takes in an A list. The body of the methods would be totally copy-pasted. And this way, if someone calls longest with an S list, they would use this method. If they called longest with an A list, they would use this top method. They do the same thing. Sometimes this is called overloading, because there are 2 methods with different signatures. They take in different arguments. So this works. I could copy-paste the method. But I don't like this. So do you like this? Do you not like this? Tell me why you like it. Tell me why you don't like it. I saw thumbs down. Why? Why? Someone shouted something. No?
What was shouted? I heard 11.
11. I don't understand. I don't understand. I love it. You love it? Any reason why? A lot of code, a lot of lines. You're right. The code is now twice as long as it needs to be, right? And in fact, not only is it twice as long, but it's like repeatedly twice as long, in the sense that it's the same code twice. So it didn't need to be the same. So it's the same code twice. I find it kind of gross. If you're reading code and the same code appears twice, that's kind of gross. Another problem is, what if you end up creating more lists? You're like, actually, I don't just like S lists and A lists. I like D lists too, doubly linked lists. Well, then you're going to have to go back and copy paste a 3rd time to get the longest method to work on D lists. Or if you create some like weird Q list class, you're going to have to create another longest method for the Q list. Also, it's harder to maintain. This one's kind of interesting, because a code's not like a car. It doesn't need maintenance. But maybe your code depends on, I don't know, other libraries, and you need to update it now and then. Or maybe you go back and discover, you know what, this longest code's kind of slow. I want to make it faster. Or you go back in and you find a bug and you want to fix it. Well, now if you have to fix something in one of the methods, you also have to remember to go back and fix it in all the copy-pasted versions. And if you forget to do that, then you'll have a sad time. So there are at least some reasons why I feel that copying the same code 3 times, not a good idea. So we've got to find something better. OK. So to find something better, I have to take a quick detour, give you a grammar lesson, and then we'll come back and talk about why the grammar lesson is necessary. So here are some instructions on how to wash a poodle. So first, brush your poodle before a bath. 2, use lukewarm water. 3, talk to your poodle in a calm voice. 4, use poodle shampoo. 5, rinse well. 6, air dry. And 7, reward your poodle. Well, that's great. But what if I wanted to wash a Malamute instead? Remember those? It's like the big dog from like, I don't know, lecture 2. So what are the instructions for washing a Malamute? Well, it'd be 1, brush your Malamute before a bath. 2, use lukewarm water. 3, talk to your Malamute in a calm voice. 4, use Malamute shampoo. 5, rinse well. 6, air dry. And 7, reward your Malamute. Well, that's basically the same thing we were just doing. We just took the word poodle and swapped it out with Malamute. So when we're faced with this problem in the real world, we're not going to copy paste this exact same set of dog washing instructions for every possible dog. Instead, we might write one general purpose instruction for all types of dogs. So we know a poodle is a dog, a Malamute is also a dog. So maybe we'll come up with a set of instructions that works for all types of dogs. So it might look like this. Here's the instructions for washing a dog. Brush the dog before a bath, use lukewarm water. I'm not going to read that again, but you get the idea. And so I'm not going to expect you to memorize this, but it turns out that in English, there's a fancy word for this. It's a hypernym. And so because poodles are a type of dog, Malamutes are a type of dog, then we can say dog is a hypernym of poodle and Malamute and so forth. So it's a more general purpose word that encompasses all sorts of different specific types of dogs. Okay, great. And so turns out you can also use the other direction. You could say poodle is a hyponym of dog, and that basically says that poodle is a more specific type of dog. Now again, I'm not going to test you on this. You might see this a little bit in Project 2, but the key idea is that in English, people had the same problem, which is you had different types of dogs, and instead of writing separate instructions, you generalized and you said, here are the instructions for washing any type of dog. So can we take this idea and put it into Java? So just like we saw from the dog example, it seems clear that S lists and A lists are both clearly some kind of list. So if we're using our fancy grammar vocabulary, then we could say list is a hypernym. It's like the more general version of S lists and A lists. Another way of putting it is an S list is a specific type of list, and A list is also a specific type of list. And we know this because they have the same interfaces for the user to interact with. So how do you tell Java this? How do I tell Java that these are both lists? So one thing I can do is I can first define a new type. Remember, there are 8 primitive types. Everything else is a reference type. So I'll define a reference type for the hypernym. I'll call it list61b. You could have called it other things. And then I will tell Java that an S list is actually a specific type of list, and so is an A list. OK, so with that in mind, we're going to try coding it, but someone complained that the dark mode is too hard to read. So let's bring it to the floor. How should we do this?
All right. Dark mode. Who wants dark?
Are we just going to do show of hands in person?
Switch dark mode, switch light mode. Yeah.
How do I do that? I was hoping you would know how to do that. Preferences. Up here. Oh, there we go. Beautiful. OK, so that's light.
All right.
I don't know what that reaction was. Oh.
You can also try
Dark. Light. What do you like? Are there other high contrasts? Ah, I don't know what this is. Ah. Intelligent light. Ah. Boo. Okay, I don't know what we're doing.
All right. So
What do you want?
hands, light mode. Yeah. All right, dark mode. All right,
What?
high contrast. All right, seems like dark mode, high contrast.
Someone wanted Darkula. I think Darkula is the default.
Darkula.
I think Darkula is the default. Okay, so what do people want? Sorry, I wasn't keeping track.
High contrast.
High contrast. Okay. Exotic. Okay, yeah, maybe we'll get more themes. The next time it'll be like bright pink. Okay.
Light on, light off.
Off. Okay. It's like watching a movie. Okay.
Great.
All right, so we're doing high contrast. All right, let's do it. So, as we were saying, okay, let me know if you like it. If you don't like it, we'll switch next time. Also, the battery's about to die, so give me a new one. Okay, So, so what we have to do is we have to define a reference type and then specify that our specific lists, the S list from last time, it's right there in beautiful high contrast font, and the A list, we need to specify that these are specific lists. So let's go back and do it. So I'm going to say public, and usually I'd say class to define a new reference type, but today I'm going to use a slightly different word for reasons we will see soon. I will say interface, and then I'll call it list61b. That's the name of my new reference type. And now, instead of specifying methods and saying, here's the blueprint of how the list61b does things, I'm going to do something a little bit different. I'm going to look through my list, and I'm going to say, you know what? Well, my list has an operation called add first. So I'll say public void add first. Oops, I'll make it generic. I'll say add first item X. And instead of actually writing the body and telling the program how to add first, I'm actually going to put a semicolon and say, this is the statement that list61bs all need to have an add first method. How is it implemented? That's specific to each list. But all lists have an add first. So this is like a blueprint of what all lists need to be able to do. So we can keep going. Public void add last, also item X. And again, I'm not going to write how to do it. I'm just going to say this list has to be able to add last. So I could go through and do this, but maybe to make a more interesting point, I'm actually going to take all of this code and just copy paste it in to see what happens. So I'll take my A list, I will copy paste it, and I'll go through, and Java starts screaming at me, so we'll go through and try to fix some things. So first, it says these instance variables, well, they're not specific to all lists. They're specific to an A list. So not all lists have an array. In fact, S lists don't have a backing array at all. Some lists maybe don't even have a size. Maybe they just compute the size on demand. So these are not things that all lists have, so we'll get rid of them. I don't want a constructor. It's not obvious that I don't, but if you come back next time, it might be a little more obvious. Insert, yeah, I think all lists should be able to insert. So instead of having the body, I will just declare that all lists have to be able to insert. What about resizing? Well, that's not really part of being a list, right? Like S lists, D lists, they don't resize at all. So in fact, this one we don't need. And another way you can tell that it's not needed is like it's private. We don't need a private method. Those are private implementation details. They're not things that the user is going to use to interact with the list. What about add first? I like that. I think list should be able to add first. What about add last? I like it. What about get first? It's good. Get last. Okay, good. Get, good. Having fun. Size, good. And remove last, also good. OK, great. So what I've done here is I've specified a type that tells me the blueprint of what things the list61b has to do. So this is a list of all things that a 61b has to do, a list61b has to do. If I give you a list61b object, you can be certain that it has all of these methods. OK, great. So that was the first step. We used the word interface instead of class. And the key idea here is that we didn't tell you how the list did its operations. How do you add last? Do you like add a link? Do you change the array? We didn't tell you that. We just told you a list of what that object had to be able to do. So here's the interface. Instead of having methods, they all end in semicolons now. OK, that was step one. Now we have to go through and do the second step, which is now that we have our general purpose list, we need to specify that A lists and S lists, they are specific types of lists. Because right now, A list could be any old class. I need to tell Java that an A list is a specific type of list61b. So let's do that. So the magic word I'm going to use, I know these lectures sometimes introduce a lot of extra words, but the magic word I'm going to use is implements. And I'll say implements list61b. And by saying that, I'm telling to Java, this A list is not just any type of object. It's a specific list61b. It's like saying a Malamute is not just any type of object. It's specifically a type of dog. So I'll say A list implements list61b. And I will come to S list and also say that it implements list61b. So this is me telling Java these are both specific types of lists. OK, I guess the generic word here was blorp. OK, great. So I tell Java an A list, it's a list61b. As S list, you are also a list61b. And now the compiler knows that this is the hypernym relationship that we want. So that's good. What's the whole point of that? Well, the point is this, because now I can come in here and say this longest method that we were about to copy paste 5 different times for S lists and A lists, and it was going to be horrible. Well, here's the trick, which is this is not necessarily an S list, is not an A list. What if this was just any sort of list61b? Then when I come down here, if I have an A list and I pass it in, that's OK, because A lists are a specific type of list. What if I had an S list instead? Well, that's also OK, and Java is OK with that too. And if later I came around and I had like, oh, let's build a D list, which also is a type of list61b, then this longest method would still work. I'd still get, hopefully, the word watching. OK, so watching in high contrast. OK, so that's what the blueprint was, and now we were able to use list61b as the argument, and now we can take in anything you want, A lists, S lists, even lists that have not been invented yet, which is pretty cool. Egg boys, I don't know what that is. OK, so let's talk about what happened, which was overwriting, and contrast it with something we saw earlier, which was overloading. So what we saw was that we had this list61b interface and it had a method signature called addLast. And the method itself was blank. We just added a semicolon. There was no actual code in here. So this signature says the interface list61b has an addLast operation. I'm not going to tell you how it's done. That is up to each of the specific lists. But I'm going to tell you that this method exists. And then when we came down here to A list, we had the exact same signature. Look, they're the same. Public void addLast item X. And because these method signatures are the same name and the exact same arguments, then we can say that the argument or the function in the subclass, this addLast method, it overrides the list61b's addLast method. So we took this method, which was blank, and we replaced it with this method, which is going to have actual information about how to add last to the S list. So the fancy word for what we did here is overwriting. Exact same function arguments all the way down, so we call it overwriting. OK. By contrast, the thing we saw earlier where you had the same name, but they had different parameters, one of them took in an A list, one of them took in an S list, that was called overloading. So these two, at first, they're going to seem kind of similar. Here's a slide that tries to tease them apart. So let's look at public interface animal. This is a statement. All animals should make noise. What specific noises are they making? That depends on the animal. And then I can say pig is a subclass of animal. So remember the hypernym-hyponym relationship? Pig, you're a specific type of animal, and your make noise method, it's going to print out oink. Right? This is overriding the method of animal because this is the subclass, and it's the exact same method signature. Public void make noise, no arguments. So pig overrides the make noise method. It says this blank one, I don't like it. I'm going to write my own more specific make noise method. OK. By contrast, if you look at something like this, where maybe I have another class dog, well, now I have two make noises. But it's not the case that one of these is overriding the other. Now it's the case that both of these are hanging around. And which one you use depends on which arguments you call the function with. So yeah, they have the same name, but they're both hanging around. If you don't pass an argument, then we could use the second one. That's just like a dog barking at the wall or barking at the tree. But maybe if a dog sees another dog and wants to bark at the other dog, maybe use this one. So here, make noise is overloaded. And usually, we would not say that one method. So here, we can say pig overrides make noise. This is just terminology, by the way, not super interesting. But you could say pig overrides make noise. But usually, it does not make sense to say that one of these make noise overloads the other. They both exist together. It's like if the power grid starts to go down, you don't say that one person overloaded the other person. You just say the power grid is overloaded, if that makes any sense. So overloading, turns out, has some real-world uses. Like this make noise one is pretty good. I also like this one in the math class. We have an absolute value method for integers. And then we have another one for doubles. They have the same name. And depending on whether you pass in an integer or a double, the proper one gets called. That's another example of something being overloaded. Question? Yeah.
So for that one frank example, the child recommend that you have a tab?
There was a question, which was, someone is not happy with the tab here, the extra space. Thoughts?
I personally wouldn't add that tab.
Oh, you wouldn't add it? OK. Should we fix it?
I mean, it's my personal style.
Oh, OK. So
I can see both.
you would like it more like that? Good? OK.
It doesn't really matter.
Requested. OK. Maybe next semester someone will come and add the space back. OK. Cool. So there's one more thing we should do just to keep our code more organized. So at this point, our overriding methods have completely been implemented. They work, right? But I'm going to add a little extra tag just to remind myself what I'm doing. And you'll do this too when you're working on projects or whatever else it is. So I am going to go through, and anytime I have a method that overrides what the parent class was doing, I'm going to add an extra tag. So I'm going to say, let's see, I go through, I didn't override any of this stuff, but aha, the insert method I did override. So I'm going to use the @ symbol, kind of like the one I used when I was writing a test. I'm going to say override. And what does this actually do? Turns out it doesn't do anything. So even if I don't have this override tag, I was still overriding. So what is the point of adding this? It's like kind of like a comment. It's like a reminder to myself that this insert method is not just any insert method. It is specifically an overridden insert method because my parent interface had an insert method that was blank, and I replaced it with this new and improved slist specific one. So I'm going to go through and add this override tag just to like remind myself or the readers of my code, hey, this add first method, it didn't just come from anywhere. It's actually an overridden version of the parent class's add first. Same thing with the add last. Same thing with the get first. I hope you're having fun. Same thing with the get last. Ooh, maybe not this one. This one's private, so we don't want that. That one did not override, so you could see that if I tried to claim to Java, hey, get last node is being overridden, Java says, no, it's not. Get last node is not from list 61b. You defined this yourself. It was not overridden from the parent class. So this tag will remind you, like, nope, that's not being overridden. OK, great. So I'll say get overrides, and this version of get also overrides, except it doesn't, because this one's private, takes in different arguments, so it doesn't override. Size of the list, I think that overrides. Remove last, override. OK, great. What fun. So what's the purpose of this? One thing, I think it makes code easier to read because it makes clear that this remove last is not just any old function. It's a function that was overridden from the parent class, which had a blank remove last. Another really good thing about override is that it catches typos. So maybe, let's say, where's my add first? I have this override tag. Maybe instead of typing add first, when I was coding, I actually typed add first it. OK, well, now we have a problem. So add first it, it is totally OK to have an add first it method. Java has no rules against having add first it. But if you write add first it, you are not actually overriding what the boss says. So if you say add first it, you're not actually replacing the blank add first implementation that was in the list61b interface. And the override tag, the really great thing about it is that if you're not actually overriding, if you put this tag, this reminder to yourself on a method that's not actually overriding, like the add first it, it will complain and say, actually, you're not overriding. There is no add first it in list61b. And I would look at this and be like, ah, I misspelled first. OK, so catches typos and also just makes code, in my opinion, easier to read. But do note that even if I don't put the override tag, I was still overriding. This is just a reminder to myself and a way to catch if I'm ever claiming to override something that I'm really not. OK, everything I said is now on the slide in words. So if you don't write it, still overrides. It's optional. But in this class, we recommend it because it catches things like typos, like add first it, add lats. OK, question? In a more complicated program structure, can you specify what overrides? Could you be more specific? Oh, I mean, do you want to like reference what the parent class? Well, I guess you maybe could. I guess maybe the reason why the override tag doesn't include more information is because the method signature is already the same. So this public void add last takes in a generic thing. Public void add last takes in a generic thing. So the signatures are already the same. So I don't know if I'd add more information.
There's only ever one thing that could possibly.
Yeah, Justin points out there's only one thing that could ever be overridden, and it would be the method with the exact same signature. So I guess for that reason, I mean, yeah, you could maybe in like another version of Java like do that, but it would just be redundant. So, yeah. OK. But in this version, you just put override. OK. There was another question? There's a question of, can I override twice? I mean, you can try it. I don't think it's possible because then it's not, then Java doesn't know which one to call, right? So if I do add last blorp x again, then Java's going to be like, well, hold on. There's two. You defined it already. And I guess the idea is that if someone tried to call add last with a single argument, Java would get confused. It would say, do you want this one? Do you want this one? Is not clear, so it complains. Great question, though. OK, and we got to try it. Cool. So, OK. So all this stuff that we did it has another fancy name. So when we specified this generic type or the more general type list61b, then we implemented it with these two specific lists. That's called interface inheritance. So to break down the term a bit, the word interface, that is the list of all the things that my list has to be able to do. All lists have to be able to add first, add last, whatever. And then the word inheritance, that came from when I said there are these two subclasses that are more specific types of list61b. They implement the list61b interface. And the interface itself, it just specifies what the class can do, but it doesn't say anything about how. That's why all the methods were blank. And one thing I'll notice that if you have an interface and you have something that implements the interface, like the slist implements list61b, then it's required that you have to overwrite all the blank methods. You can't leave any methods unoverridden and blank. You need to specify exactly how all of the methods in the interface are implemented. So for example, in my list61b, I had insert, I had add first, I had add last. So anything that claims to be a list, it has to implement and overwrite all methods that are listed in list61b. So it's kind of like, I don't know, maybe you have like a blueprint that tells you this is how a key works, or like a lock works. It has to be able to lock, it has to be able to unlock. And so anything that you claim is a lock, it has to have a lock operation, has to have an unlock operation. And you could, implement that lots of different ways. Maybe some locks use a key, some locks use a combination, some locks use a fingerprint or whatever. But all the locks that you ever build have to have a lock operation and an unlock operation. If you build a lock and there's no lock operation or there's no unlock operation, then can it really be a lock? I guess philosophical question, but at least Java would say, no, that's not a lock. It does not do all the things that locks have to do. So anytime you implement an interface, you must take all of these blank methods and overwrite them with actual implementations, or else Java will fail to compile the program. So for example, if I said, you know what, list61bs, they have a new extra operation. I think all lists should be able to prove. I don't know what that is, but maybe all lists have to be able to prove. If I add this extra blank method and I say all list61bs must prove, then you'll see that slist no longer compiles. It says, slist, you don't count anymore. You're not a real list61b because you don't prove. And same thing with alist, you don't count either because you don't prove. So that's what happens if you don't override all the methods. OK. Great. So this is really powerful. Here's a picture of it. On the slides, usually, if there's an interface, it's in white. There's a class, it's in green. So in case you ever see these pictures. But this is really cool. We solved our problem from today, which was that longest method that used to have to be copy-pasted if I had slist and alist. Now it works on any type of list, slist, alist, dlist. Even if like 20 years from now you go and invent the qlist, well, as long as it follows the list61b interface, then the word utils longest method can take in the qlist as an argument too. That's great. OK. So just to be really clear, I guess there's one final little note. Sometimes people bring this up, sometimes they don't. If this makes no sense to you, I guess this can be your one slide break. But sometimes people complain and they say, well, wait a minute. Back in lecture 3, you told me about the mystery of the walrus, the golden rule of equals. And you said that when I pass in an argument, so I'm calling longest on A1, and when I pass in this argument A1 to the input list variable, you told me you just copy the bits. And you also told me that this input list variable, it was declared as a list61b, but you're copying the bits from something that is declared of type a list string. So how can something of a list string go into list61b? Somehow these types don't seem like they match. Doesn't Java complain? How is Java OK with this being a address of or a reference to a list61b, but this memory box, the bits that I'm copying in, they're a reference to an a list. So why is that OK? Well, the little syntactic trick that makes this work is that if I define or I declare a variable saying input list is of type list61b, this memory box can hold a reference to any type of list61b. So it can hold a reference to an a list. It can hold a reference to an s list. That's OK because an a list is a list61b. So that's the little English trick that makes this work. Just in case you were uncomfy with this, hopefully now you're not. OK. In the interest of time, because we did a little dark mode demo, I'm not going to show this to you. But after we go home, I would suggest staring at this. This is just 2 lines of code. Try and figure out if this actually compiles and if it works. Just to make you do it, I'm going to skip the answer. You don't get to see it. But go home and try it out, and let me know what you think. OK. So We talked about interface inheritance. We said you inherit all the signatures. You inherit what the list has to do, or you like inherit the list of all locks have to lock and unlock, but you do not inherit the implementation. When you wrote the interface, all the methods were blank, and you had to override all the blank methods. So there's another type of inheritance out there, though. This one is called implementation inheritance. So this time, you're not just inheriting the blank signatures that say this is what a list has to do. You're actually going to inherit some of the implementations as well. So now the subclass not only gets the blank signatures that it has to go through and override, it also gets some actual code. So let's go see what this looks like. I'm going to write an implementation and then have the subclasses implement or inherit that implementation. OK, so let's do it. I'm going to come over to list61b, and I'm going to say, you know what? I actually think all lists should be able to print. So I'll say public void print, and I'll say what prints all the items in the list. OK, great. So I think all lists should be able to print. Well, right now, they don't print, so they're complaining. So maybe instead of just giving the blank print method to all of my subclasses and say, here's a blank print method, you deal with it, you overwrite it, I can actually say, not only am I gifting you this print method to all my subclasses, I'm also gifting you a default implementation. So if you're lazy and you don't want to write a print method, I'm going to give one to you. So this way, not only am I inheriting the signature, I'm also inheriting code. So I could first start by trying to write code. It complains. It says, nope, you can't have code in an interface. But if I put the default keyword, now I can. So the default keyword says, here's a default implementation that is given to all the subclasses. So at first, this seems weird. How can I possibly write a print method for any type of list61b, A list, S list, Q list? How can I possibly write a print method if I don't even know what type of list it is? Like, look, there's no instance variables because those are private and specific to S list or A list. There's no array. There's no sentinel. How the heck am I going to be able to print things, right? But it turns out I do have some things at my disposal. So I don't have instance variables. I don't have private methods. But I do know that any type of list, even ones that have never been built yet, that are coming later, every list that I could ever build that implements list61b, it's going to have an insert method. It's going to have an add first method. So I can use these methods even though I don't know what specific type of list it is. That's kind of cool. So I'll say maybe I'm going to start at 0, and I'll say I less than size. Why can I use size? What licenses me to do this? Because every list ever that implements list61b is guaranteed to have a size method. That's what my interface says. So I'll go through from 0 to size, and then I'll say something like print. OK, great. And maybe I'll do get the ith item. And again, what licenses me to use get? It's the fact that every list61b, S list, A list, D list, Q list, Z list, all of them have a get method that will be overridden later. So even though I don't know what the get method is doing, I'm safe to call it because I know every single list out there has a get method. OK, maybe I'll print a new line at the end just for aesthetic purposes. OK, so there's my default print method. I guess I can go into my isAdemo class. So what is this doing? It just calls the print method on a S list. So I'll say I declare there's a new S list. I put it in a memory box of type list61b. We saw earlier that's fine. And I'll add the words elk dwell on existential crises. And I'll try to print it out. So if I run it, I will get elk dwell on existential crises. And the really cool thing about this, I get elk dwell. But the really cool thing is that if you look in the S list class, look, no print, right? That's not the print method. That's just some print line call. So even though my S list did not have any print state or print method whatsoever, the S list still inherited the default method that I wrote in list61b. And the same would go for an A list. There's no print method. But if I had an A list with these items, I could still print them out, which is pretty cool. So there's my default method that I wrote. How was I able to write this despite not knowing what type of list? I leveraged the knowledge that all lists have a size method, all lists have a get method, so I can safely use those. OK, and then I was able to print elk dwell on existential crises, even though my S list did not have a print method, because it inherited the print method that I wrote earlier. So question for you then, are we done? Can we just have every list use the default method that we provide to all of our subclasses? Or maybe, just maybe, is this method a little bit slow for a specific type of list? Or maybe both type of lists. So what do you think? Is it too slow for some types of lists? Is it kind of fast? Well, I guess I could start with an A list. So in an A list, getting size, pretty quick. Remember we had our size variable, you just return it. What about getting things in an A list? How fast is that? Well, we had to go in the array and get an item. But in an A list, getting something from an item, pretty fast, so I'm OK with that. What about S lists? Well, what is the size method of an S list? You just get the size. It's an instance variable. It's pretty quick. How do you get something in an S list? You start at the beginning. You scan. OK, that's the problem, which is, well, if I loop through all the items and I try to call get 0, get 1, get 2, then I'm going to be calling get over and over again. What's the S list going to do? I'm going to call get 0, scan to item 0. Get 1, start at the beginning, scan to item 1. Get 200, start at the beginning, scan to item 200. Get 201, start at the beginning, scan to 201. So I'm scanning the list over and over and over again to repeatedly get all the items. And if I do like get 500,000, scan to item 500,000, get 500,001. I start at the beginning all over again, and I scan to 500,001. That's how we wrote our get method. So turns out, if you stare really closely, there's like a double nested for loop happening here. So I don't like it. So it turns out this method is too slow for S lists because I'm repeatedly scanning the array over and over, and it's wasting time. So how do I make it better? Well, it turns out that if you do not like the default method that was gifted to you, so now we're the S list, and our parents, the list61b, they like gifted to us this default method and said, you don't have to write a print method if you don't want to. But you know what? I don't like the print method that was given to me, so I'm going to write a better one. I'm an S list. I know specific S list things that my parent, the general list61b, did not know. So I'm going to say, I actually know, more than my list61b parent does. I trust myself to write a more efficient print method. So let's write a more efficient print method. So I'm still going to write public void print. It's the exact same function signature, exactly the same. OK, great. And then I'm going to add the overrides tag just to remind myself that I'm actually overwriting what the boss says. And this time, I'm really, truly overwriting. I was given this implementation, and I'm saying, no, I reject it. I'm going to write my own because I trust myself to write it more efficiently. And again, why add this override tag? If I don't add it, I'm still overwriting. But by adding it, helps me catch things like, well, if I said pernt, I would, it's OK to have a pernt method, but this would not actually be overwriting. So that's why I like to have override. OK, so now we're in the S list. We have access to all these wonderful S list things. So I can write an S list specific print method. So maybe I'll do something like, maybe instead of like scanning over and over every time and calling get, maybe I'll just have a little pointer like we've seen in all the previous lectures. So I'll say I'm going to start at sentinel.next. And I guess I'm going to go until p is not equal to null. And I guess every time I step, I will step p equals p.next. So I'll scan through the array. And then every time I get to an item, I'll call print p.item. OK, great. And then at the end, I'll add a new line just to make things look nice. So I wrote my, sorry, the high contrast is messing with me. OK, so I wrote my own custom print method, and I overwrote what the boss says. I rejected the default method that was given to me. I wrote my own because it's more efficient, and I trust myself to use S-list specific things. Whereas the default method had to work for all the 61Bs, so it could not do that. Just to really, really convince you that this is about to be executed, I'm going to have the print method in slist say something like, the boss doesn't know what he's doing. OK, so now if I go back to is a demo, what's it complaining about? Oh, semicolon. OK, so if I go back to is a demo and I run this demo again, well, now I hope you're really excited. Well, now we get elk dwell and existential crises, but I also get the boss doesn't know what he's doing. I also guess I had extra L in there. OK, whatever. So now I get the boss doesn't know what he's doing, elk dwell on existential crises. And so what this tells me is that I did not execute the default method. I actually executed this overridden method, the one that had this extra print statement. And that's good, because this one is faster, and we want this one to execute. OK, and just to really convince you that the override tag, it still will work if I don't have the override tag. So even if I don't tag that I'm overwriting, I am still really overwriting because I'm replacing the method. I still get the boss doesn't know what he's doing. But why might I want to add the override? Because again, what if instead of print, I said pernt? Well, it's OK to have a pernt method. lists can print all they want. But if I add print and I run this as a demo again, you'll notice that I am no longer using the overridden print method. There's no more boss doesn't know what he's doing because they didn't actually override print. But if I added the override tag, then Java will complain and say, oh, you're not overriding. And I would look and be like, ah, that's not print, it's print. OK. So do add the override tag just in case you printed instead of printed. And if you don't like the default method, you can override it. In this case, you're really deleting what the parent class gave to you and writing your own preferred print method. OK, so questions before the last topic? Well, what did you want me to do? Override what? Can I overwrite the override? I feel like I don't follow.
You can override an override if you have like 3 layers of class.
Oh, I see. You want like multi-generational inheritance. So we're not going to talk about multi-generational.
Can you override the decorator?
Why would I? Oh, OK. So you want me to like override the override? I don't know if this is doable. I think it just starts complaining and getting confused. I don't know. Maybe we can try it afterwards.
Some like but it's more function on function. It's part of some library, I think.
Yeah, it's part of some library. Talk to us afterwards.
Technically,
I am intrigued,
override,
but
you probably don't.
in the interest of getting everyone out on time, after lecture. Fun question though. One more?
Yeah, after overriding the print method from that object to access the
Can I access the interfaces print method if I am in slist?
super.print.
I can do, yeah. So there's a keyword super. Come back next time for it, so you can. But
Like you're gonna call the method in like your main.
like this? Oh, you want me to call the parents method in main? I actually don't know if that's possible. That's a good question. So can I call the interfaces print? I feel like I can't because I have deleted what the parent gave to me.
Yeah, you can call it directly.
Yeah, so my intuition is that unless you do something super strange, you've deleted and overridden what the boss said, so you no longer have access to it. It's a good question, though. OK, so I have one final topic to talk to you about, which is if you looked at this, maybe you noticed something that was a little bit not obvious. I just kind of blazed through it to try and convince you. But let's take a look at it a bit closer, which is let's look at this line right here, which says I declare there is a variable of some list called some list. It's of type list60omb. And I assign it not just to any list, but specifically an S list. And so the question is, I have this variable. It's declared as a list60omb. Then I assign it to an S list. So when I call someList.print, which print method am I actually calling? Am I calling list60omb's default, slow, sometimes general purpose print method? Or am I calling slist specialized, boss doesn't know what he's doing, slist specific print method? So at first it doesn't seem like totally obvious. Maybe it calls the list60omb one, maybe it calls the slist one. So it's not totally clear. And by the way, why is it OK to write this line of code? Because the memory box for someList, which is of type list60omb, it can hold anything that is a list60omb, including slist. So in case you're not comfortable with the types not matching, it's OK because slist is a list60omb, just like how poodle is a dog or Malamute is a dog. OK, so how come this print method uses the slist one like we saw earlier? So why did this print out the boss doesn't know what he's doing? How come it didn't use the list60omb's version, the default version of print? And so to figure out why this is happening, I have to introduce a topic that has historically been just like super annoying. We're going to try to introduce it a bit more cleanly this time because it's kind of weird. It's easy to get really deep into the weeds and talk about arcane Byzantine edge cases, but we'll try to keep it simple for you this semester. So here's the idea, which is every variable that you ever create in Java is going to have actually not one type, but two. So what do I mean? Well, every variable is going to have a compile time type. Sometimes people call it a static type. They mean the exact same thing. And this is the type that you specify when you declare the variable. So like, look at this line right here. I declare that there is a variable called lt1, and it is of type living thing. So that means that lt1 has the static compile time type living thing. And this will never, ever, ever change. When you declare a variable, that's it. You cannot redeclare it and change your mind later. So this lt1 has static type of living thing, and that's it. It's living thing forever. OK. By contrast, all variables have a second type, which is called their runtime type. Sometimes people call it the dynamic type. They mean the exact same thing. And this is the type that you specify when you actually assign the variable, which currently is null, to an actual object. So when I say lt1 is equal to new fox, when I use the new keyword and I shout the location of my fox and I put it in the lt1 variable, I am saying that the dynamic type of lt1 is actually fox. So there it is. The static type is living thing because I declared it to be a living thing. The dynamic type is fox because when I assign it to an actual thing, the thing that lt1 is pointing at is not just any living thing, it's specifically a fox. So that's the runtime type. I can make more boxes. So here I have animal A1. I declare that there is a variable called A1. It's of static type animal because that's what I declared it to be. So there it is. It's my box. It has static type animal. That will never change. Like, look, it's right on the box. Can't change that. And then I copy the bits from lt1 into A1. So what that will do is it will cause animal to point to the same fox. So the dynamic type, the thing that I'm actually pointing at in the runtime, that's a fox. But the static type, it's animal. I keep going. Here's one where I declare there's a fox variable. There it is. And then I say new fox. So it's pointing at another fox. So the dynamic type is fox. I can even go to lt1 and I can say, right now it's pointing at this fox. I don't like that. I want it to point to a squid instead. And if it points to a squid, the dynamic type changes because now it's pointing at a squid instead of a fox. But the static type does not change, always a living thing. OK, so there's two types. To figure out the static type, you look at how the variable was declared. To figure out the runtime type, you see what object it's actually pointing at right now. So why am I telling you this? Well, here's the rule that you have to know then, which is if I have an object and it has two different types, the compile time type and the runtime type, and they're different. So like we saw earlier, the compile time type was list61b, but the runtime type was slist. If they're different and the runtime type overrides the method, like the slist overrode what the boss said, then the rule is you're going to use the overridden method instead. So you're going to look at the runtime type and see if the runtime type overrides the method. And if it does, use the runtime type's overridden method. So like we saw from earlier, right? What is the static type? It's list61b because that's what I declared SUMList to be. What is the dynamic type? It's slist because it's currently pointing at an slist. And because slist overrode what the boss said, had its own custom-built print method, we're going to use the dynamic type's overridden method instead. So that's the rule you have to know. Sometimes people call it dynamic method selection, but that's the rule. If you override and the dynamic type, or if the dynamic type overrides, use the dynamic type's overridden method. OK, so before you go, I do want to quickly point out, I guess first, do you have questions about dynamic method selection? This term's a bit obscure. It's what we use in this class. It's just this one rule that you have to know. OK, before you go, I do want to briefly mention that in semesters, I know this says pre-2018, but as recently as last semester, and you need to correct me if I'm wrong here, we used to have dynamic method selection questions that were like kind of ridiculous and started testing a lot of edge cases. So we were like, what happens if you override and you overload at the same time? Or what if like you override and then you overload and then you like pass in, I don't know, like the subclass as an argument. So we had more complicated, obscure edge cases. But to be honest, we just don't find those totally interesting. They're more like Java trivia than something core to data structures. So you might see questions in past semesters that are a bit obscure, that just seem so confusing. It's like, wait, why do I have like 5 different make noise methods with different arguments? So if you ever see a question like that, they're no longer in scope for this semester. So the rule that you have to know for this semester to make everything work is you follow this rule. If the dynamic type overrides, use the method that was overridden. Did I miss anything in my scope discussion? OK, if you're not sure about scope, by the way, you can also just come and ask us. Wait, I have one more slide. OK, so I guess if you have to go, you can go. But the final thing I wanted to summarize is just that the interface inheritance, that specifies what? You inherit the rules, or like the list of the things that a list can do. You did not inherit how to use them. You just inherited what the list can do. All lists have to be able to add last, but you did not inherit how. By contrast, implementation inheritance, the one with the default keyword, you inherited how. You inherited the actual implementation. And in both cases, we have to specify is-a relationships. So like an S list is a list, a dog is an animal, a poodle is a dog. So implementation inheritance, some people like it, some people don't. But since you're all gone, you're going to have to come back next time and I'll tell you why some people like it, why some people don't. Okay, see you next time. Okay.